Okay, so in this video, we're going to talk about structure and nomenclature again based on the slides given. Okay, all right, so first and foremost, you have to learn how to classify them. Okay, so when we talk about hydrocarbons, we're talking about compounds that contain mainly of carbon and hydrogen. And these hydrocarbons are normally divided into these two groups, which is the aliphatic and the aromatic. So under aromatic, most of the time we talk about benzene, okay, because aromatic compounds will involve just benzene. So this will be in chapter 2. All right, so for this chapter we're going to focus on the aliphatic side, which is talking about saturated and unsaturated hydrocarbon. So when we say saturated, we're talking about CC, all single bonds, so it can be CC carbon bonds or CH carbon bonds, they're all single bonds. Whereas in unsaturated, you have the presence of a double bond. It can be between CC carbon double bond or C triple bond C. Okay, so these are the unsaturated, hence why we have alkanes here. And then the alkynes, double bonds. So cycloalkanes are also saturated because they're also single bonds, except that they form a cyclic. And alkanes, okay, it can be the straight chain, or it can be all right, straight chain also considered saturated. All right, so sometimes you get the ones with branching. All right, so first and foremost, alkanes are the saturated, okay, saturated hydrocarbons. They contain only carbon-carbon single bonds, okay. Saturated means that each carbon has a maximum number of hydrogen bonded to it. Okay, what is the maximum number we're talking about here is each carbon can only accommodate a max of 4 bonds. Okay, a max of 4 bonds. So that's why in each carbon, you can only see 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so that is what it means by saturated. Each carbon has a maximum number of hydrogen attached to it. Sometimes it can be also carbon-carbon, all right? But in conclusion, each carbon atom can only accommodate a maximum of 4 bonds. It can be with hydrogen, it can be with other functional group, it can be carbon-carbon. Also, total up must be 4. Even in the unsaturated compound, when you have alkane, it will be CC double bond, right? And then you have 1, 2. So that makes 1, 2, 3, 4 bonds. That's the max, okay? Same goes for this. There'll be 1, 2, 3, 4. So this carbon will also have a maximum of 4 bonding, okay? Alkanes are also known as aliphatic hydrocarbon because the physical properties of the higher members of this class resemble those of long carbon chain molecules we find in animal fats and plant oil. So basically, when we talk about long carbon chain or long hydrocarbon chains, we're talking about petrol, oil, even our proteins, okay? So all mostly fats. These are mostly all long hydrocarbon chain, okay? So that's why they're also known as aliphatic hydrocarbon. Okay, so fatty carbon. All right. So alkene is the first unsaturated hydrocarbon. Okay, they contain one or more carbon-carbon double bonds in the molecule. So it can be C double bond C, C triple bond C. Okay. So far, there's no C quadruple bond C, no such thing. So normally we look at CC or C double bond, C triple bond. Okay. Okay, alkene has fewer hydrogens than alkane, so with the same number of carbons because of the double bond. So the general formula is CnH2n. Remember, alkane's general formula is CnH2n plus 2. Okay, so alkane will have 2 carbons lesser. Alkene will have 2 carbon lesser compared to alkane. Okay, so when you have the double bond consists of 1 pi bond and 1 sigma bond. So if you look at this picture here, 1 sigma bond, 1 pi bond. Okay, so there are 2 different bonds. So each carbon is sp2 hybridized I can't remember if you learned in in physical chemistry. Okay, we're talking about hybridization, okay, of the orbitals. Okay, so in this case, the carbon atom undergoes sp2 hybridization, means it's a hybrid between the s orbital and the two p orbitals. Remember, p orbitals, you have x, y, and z. So out of the x, y, and z, two of it is merged with the s orbital, so it becomes a hybrid. Okay, then this will lead to the shape of the structure itself will be trigonal planar, and then they have a bond angle of about 120 degrees. So if you notice, when you have a 3D structure, or if you look in the internet, you will see that sometimes you see it comes with an angle. Okay, so this is because of the hybridization. Okay, so the bond is much weaker than the bond of a CC double bond. Okay, the bond is much weaker than the bond of a CC double bond, making it much more easily broken. As a result, alkene undergo many reactions that alkanes do not. So because of the presence of this double bond, right, it actually makes alkene weaker than alkane in terms of the bond breaking. Okay, it's easier to break the bonds because of the presence of a weak pi bond. So sigma bond is stronger than the pi bond. Okay, sigma bond is stronger than the pi bond, but because of the presence of the pi bond, okay, the energy required to break the pi bond is lower than the sigma. So it will break this pi first, because if you remember, if it's saturated, it's all single bond, right? All single bond. But because in the alkene you have the double bond, the presence of this sigma of this pi bond, it weakens this structure, the bond that is between the two carbon. So when it weakens it, it makes it easily to be broken. Okay, so in that case, it causes alkene to undergo many reactions as compared to alkane. So alkane will have, in terms of reaction that it can undergo, is lesser in alkane and more in alkene. Okay, and then you have alkyne. Alkyne is a carbon-carbon triple bond. Okay, so terminal alkynes have terminal as triple bond at the end of the carbon chain. So it can be at the head or it can be at the tail. Okay, as long as at the head or the tail, we call them terminal alkynes. Internal alkynes can be anywhere, alright. Have carbon atom bonded to each carbon atoms of triple bond. So anywhere in the structure, alright. In the middle, then it's internal alkyne. But if it's either at the head or the tail of the structure, that makes it a terminal alkyne. And then for its general formula, okay, it will give 4 fewer hydrogens. So just now we have CnH2n for alkane. So alkene. So we have CnH2n, right? And then for alkane, it is CnH2n plus 2. So in alkyne, you minus 2. So 2 hydrogen lesser. Okay. So what are the uses of all these alkynes? So most of them alkane will be available in nature, primarily in natural gas and petroleum. So actually, the oil that we use, the fossil fuel petroleum, are all complex mixture of compounds which are hydrocarbon containing of 1 to 40 carbon atoms. So that's why you have this cracking and all that. So you have the long hydrocarbon chain. When you have a long hydrocarbon chain, when you have a long hydrocarbon chain, you need to keep cutting. So when we crack it, we break the carbon chains, then we get different products. Okay, so that's why as a future chemical engineers, you need to know the fundamental of these organic compounds. Okay, because petroleum will be your main product that you have to deal with. Okay, so if you look at this picture, you can see that in crude oil, when we say crude oil is oil that you extract direct from the source, that has not been processed. Once you process, then you get all these substances out, right? Sources of alkane. All right, so you can read out a little bit. So these are one of the uses. Okay. Okay, now we go into the structure alkane, alkene, and alkyne. So structure alkane, alkene, and alkyne, already we talked about it. So alkane, basically they're all saturated. Okay, all saturated. You see they're all single bond, especially the between the carbon is all saturated. And the unsaturated, you have ethene, C double bond C, and then alkyne, you have C triple bond C. Okay. So isomerism, okay, remember isomerism, same molecular formula but different structural formula. So this is called isomerism. Okay, different compounds with the same molecular formula are called isomers. Alkanes with carbons connected to no more than 2 other carbons are straight chain or normal alkanes. Okay, so if it is a straight chain or normal alkane, normally you see like this, right? It should to no more than 2. Okay, that will be a straight chain, because here will be hydrogen, here will be hydrogen again, hydrogen, 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 hydrogen. So it will not exceed 2. But if it's connected to 3 or 4, then most of the time it is branched. It is a branch chain already. Okay, so if you look at this, so it'll be 1, 2, 3. So this one we consider is a branch already. Okay, so this is the isobutane. Okay, this is one isobutane. This carbon has 1, 2, 3. There's one here, there's one here, and then another one will be hydrogen, right? And then this one is all straight chain. So look at the number of carbons, 1, 2, 3, 4, 1, 2, 3, 4 is the same number of carbon. But this is straight and this is branched. That is the main difference. Okay, so this will affect later in the physical properties. Okay. So condensed structures, all right, you need to know this because in the exams, sometimes they ask you to draw the structure, but they give you the formula in this format. Like it's written in this format. Okay, so from here you have to deduce the structure, whether you want to draw it in skeletal or you want to draw it like this, which what you used to do. But I highly encourage you when it comes to drawing to use this particular method. Okay, use this method for drawing. Why do we use this method? At least you can count the carbon and you know the number of carbon is right. You can count the hydrogen correct or not. If you use this method, the skeletal method, the only thing when it comes to the skeletal method is when you get overexcited. You know butane is 4. 1, 2, 3, 4. Sometimes you can go more than 4. Okay, so you will carelessly make it. Can be easy. It's easy to make a mistake using the skeletal structure. So I highly recommend for you guys to draw in this method. Okay, please draw in this method if possible. Okay, and then these are condensed structures. Okay, condensed. So from here you can actually draw this structure out, and then when you have the structure like this, it's easier to name. Okay, now we go into nomenclature and the IUPAC system. So the IUPAC name of alkane with the unbranched chain of carbon atoms consists of 2 parts: a prefix that indicates the number of carbon in the chain, and a suffix ane to show that the compound is saturated hydrocarbon. So this is where you get your methane, ethane, propane, butane, pentane, etc. Okay, so your prefix will be will be determined by the number of carbon atoms, and then the suffix will be ane if it is an alkane. If it is an alkene, the suffix will be ene, and you have to indicate where is the presence, at which carbon the double bond is present. Okay, so alkane can be also a functional group. So this is what we refer to as another functional group. Okay, sometimes we call it a branch as well. Okay, sometimes we call it a branch of, if it's alkyl group, normally we're talking about hydrocarbon branching. Okay, so if it is a methyl alkyl group, then we call it it's the same. The suffix, the prefix is determined by the number of carbon atoms, okay? But the N is not, you don't use A and E, instead you change it to YL. Okay, you change the A and E to YL. So for example, you have this alcohol, sorry, when you have this methane, right? So here's one example. Okay. All right. So this longest chain would be 3 carbon, so prop. All single chain, so propane. Now this is a alkyl group. It's a branch already. So we call it, instead of, because it's only one carbon, so it's met. So methyl, all right, and then carbon number 2. So 2-methyl propane. Okay, please don't write 2-methane propane. It's incorrect. So if it is a branch, all right, if the alkane is a branch, then you have to change it to alkyl. The A and E change to YL. Okay, here are some examples. Okay, if it's a single, if it's one carbon, if it's an alkane, we call it methane. If it's an alkyl group, we call it methyl. All right, ethane, ethyl, propane, propyl, butane, butyl. Okay. Now this is classification of the alkyl groups. So we look at the carbon in question here. If there's another carbon chain, it can be 1 carbon, it can be 2 carbon, as long as it's a chain, another carbon chain, all right, attached to this carbon, only one, whereas the rest is all hydrogen, this is primary. If there are 2 carbon, all right, 2 carbon attached to this central carbon, that will be secondary. If this one has 3, so tertiary. If it's all 4 carbon, that will be quaternary. All right. Now naming the compounds. Okay, so we have the locant, prefix, parent, suffix. So the locants, where are the substituents and functional groups? Prefix, what are the substituents? Parent, how many carbons? Suffix, what is the primary functional group? So normally we always determine the parent first. So the parent will be finding the longest chain. A parent hydrocarbon chain, we look at the longest chain. What is the primary functional group? So if it's all saturated, you have the alkane. If there's a double bond, you have to find the longest chain that consists of the double bond or triple bond. That will be your parent and your suffix. Okay, and then also do not forget, if there's a double bond, triple bonds, you have to remember to give them the number at which the carbon is attached to. Okay, prefix, locant, this is talking about the other substituent groups, okay, like methyl, ethyl, or if you have bromo, chloro, all right. Okay, so first of all, you have to find the hydrocarbon chain. So do not get tricked by the structure, all right? Like in this example here, if we follow the straight chain, you only get 5 carbon. But if we go until this 4th carbon and go up, you give 6 carbon. So because going up gives you 6, this will be your parent. You need to find the longest chain. Please bear that in mind. You must find the longest. Okay. Same goes for the second example. If you look at this straight structure here, it's only 1, 2, 3, 4, 5 carbon. But if you look from top to bottom, you will get up to 7 carbon. So because 7 is bigger than 5, this is your parent. That's why it becomes heptane. Okay. So to find the parent carbon chain and add the suffix, okay, you must find the longest chain. Okay, it does not matter the chain is straight or it bends. So you have to be very careful. All right, especially when it looks like they are branching. Okay, this is where you have to be careful, because this is most of the time a trick to prevent you from noticing that the longest chain is not in the straight chain. Okay. So also note that if there are two chains of equal length, pick the chain with more substituents. So if we look at these two examples, both will give you 7 atoms, longest chain 7 atoms. This one will give you 2 substituents, this one only 1. So this one will only be 1 substituent group. This one will give you 2. So in this case, if you have the longest chain is the same number, find the one that gives you more substituent group. Okay. Number 2, number the atoms in the carbon chain to give the first substituent the lowest number. Okay, so if it is saturated alkane, it's very easy. You find the one at the lowest number. Okay, but if there's a double bond, that one you have to be careful. Priority should be given to where the double bond is. Okay, where the double bond is, then you need to find where the double bond will give you the smallest number. Same goes for the triple bond. Okay, if the first substituent is the same distance from both ends, number the chain to give the second substituent the lower number. Okay, all right, so in this case you got 1 2 3 4 5 6, so you know that 6 is hexane already. Okay, so hexane. If I follow this one, okay, 1 2 3 1 2 3, right? So in this case, this one will give me 2 3 5 tri methyl hexane. Whereas if I go from the right, I will get 2 4 5 trimethyl hexane. So because it's a 2 4 5, this is bigger as compared to a 2 3 5. So that's why this is the correct one, this is incorrect. Okay, right. So when numbering a carbon chain result in the same numbers from either end, assign the lower number for alphabetical first to the constituent. Okay, so this is in the case, let's say you have methyl and ethyl. Alright, methyl and ethyl. So when it comes to methyl and ethyl, even though methyl is only 1 carbon, this is 2, right? But alphabetically, E comes before M. So when you name it, alright, this is 1 2 3 4 5 6 7, it will be heptane again. Okay, so you got 2 substituent group. You have ethyl and methyl. Okay, so on this left, it will give you 3 and 5. On this one will give you 3 and ethyl will be 5 and 3. So in this case, we go from 3 to 5, small to big. Okay, small to big. But remember, this is for saturated. If you have any case like the earlier ones, right, if you have double bond especially, priority given to where the double bond is. Double bond has to be the smallest configuration first, then only you worry yourself about the presence of the substituent group. Okay, name and number the substituent. Name the substituent as alkyl groups if it is alkyls. Okay, every carbon belongs to either longest chain or a substituent, not both. Each substituent needs to its own number. Now if you have, okay, if it's 2 or more identical, especially when you have the same one, like methyl appears 2 times or 3 times, okay, you have to make sure you itemize exactly where it is present. So for like this example, I'll give you a different example. Okay, and then okay, so in this case, the methyl group appeared twice, but on the same carbon. Alright, so this is obviously carbon number 2 from this structure. So if it's carbon number 2, you would definitely write 2, right? But remember, there are 2 of them. So when there are 2 of them, you have to write it twice. So 2 2, then only dimethyl butane. Okay, if it's on the same carbon, if it appears twice, you have to write it 2 times as well. Okay, Combine substituent names, numbers, and parents and suffix precede the name of the parent by names of the substituent. Alphabetize the number of substituent, ignoring all prefix except ISO. ISO as in isopropyl and isobutyl. Okay, so remember you have dimethyl and ethyl, right? Okay, ethyl. Okay, alphabetically D comes before E, right? But because you have to remember, we add the di because there's more than one, but you arrange them in terms of ethyl and methyl first, then only you put the di there. Alright, so you have to arrange in terms of alphabetical. We arrange the groups first, then regardless whether there's 2 or 3 present, you arrange the alphabetical based on the substituent group present. Okay, so naming alkanes, I think you had some introduction to this as well, and furthermore on YouTube there are plenty of videos to help you guys as well. Okay, so these are some more examples. I'm not gonna go into detail anymore. So this one, probably most of it you just need to do a lot of practices. Okay, alkene is the same except you change the A and E to E and E now. Okay, so it's the same. Sorry. Okay, so it's the same rule again. Find the longest chain. For a compound double bond, suffix is diene. Okay, if it appears more than one time, if the double bond appears more than once, you have to remember to include the di in front of the E and E, and then you make sure you identify which carbon the double bonds are present. Okay, so read this. Carbon-carbon double bond take precedence over alkyl groups and halogens, determining the main carbon chain and direction in which it is numbered. So this is what I mean by when you do the numbering, alright, you have to prioritize the carbon-carbon double bond. That should be the lowest value first, okay? Then only you move on to the other alkyl groups, or if it's other if it's other functional groups, okay? Name with the lowest functional group, okay, it's the same. Side that substituent is the same. This one you just have to keep on practicing. Okay, now when you have a cyclic structure, a cyclic alkene, when we say cyclic, you have to include the word cyclo. Cyclic means when from the first carbon it will connect and then end at the first carbon. This one will form a cycle. So when you see that kind of structure, if there's a single double bond in there pun, alright, even though it's a single double bond, you still have to put the word cyclo in front. Alright, same goes for alkane. If the first carbon and the last carbon is connected together, then it's a cyclo. If it is an open chain, a straight chain like this, then this is no need to put the word cyclo. Alright, but if you get a cyclic like this, a triangle or a pentagon, okay, a pentagon, or you have the hexagon, alright, these are all cyclos. You have to remember to put cyclo, hexane, cyclo, pentane, okay, or cyclo, pentene, cyclo, hexene, okay, you have to remember to put the cyclo. Okay, and in a cyclo, you have to make sure your double bond is your first carbon. Then it makes life a bit easier for you. So in a cyclic alkene, the alkene functional group is given the number 1, but the number 1 is left out of the name because automatically you know that that is your first carbon. If there's only one double bond. If there is 2 double bond like this one, you have to make sure you identify exactly what at number what the double bond is present. Okay. Cis trans. Okay, I think you remember this one. So cis and trans. All right. Cis can also use the prefix Z. Trans can also use the prefix E. So cis. If it's a cis, means you can look at either hydrogen, okay, they're on the same side, and if it's trans, they're on opposite ends. Okay, so you can also use Z pent to in or E pent to in, but I think cis and trans is easier to remember. Okay, so when do we know we need to identify if it's a cis or trans cis or trans in the naming or not? Okay, pay attention to the double bond. Is it in the center of the diagram? If it is in the center of the diagram, then yes, you have to put the cis and trans. Okay, like in this one, this is not a cis or a trans because you have the hydrogen. Okay, it doesn't show any alternating or that is in the same side. Okay, so this one is definitely not cis or trans. And then this one, you have carbon here, carbon here. This one, double. Okay, so this is also not cis or trans. But in this one, you have to find a common element. So normally we look for the hydrogen. Okay, look for the hydrogen. If the hydrogens are on the same side, then it's a cis. If on opposite side, it's a trans. Okay, so remember if it's asking for cis and trans, you have to look at the structure. If they highlight the double bond like this, then be very careful. They are looking for the cis and trans in front of the naming. Okay, so two identical group on the same side of the double bond, cis 2-butene, trans 2-butene. So these are 3D structures. You can see it's like this. This one is on the same side. Okay. Okay. So when you have cis and trans, this will affect the stability of the alkenes. So what is most important? Cis is more stable. Trans is more stable than cis. Okay. Two most important factors governing alkene stabilities are the van der Waals strain, destabilizing when alkyl groups are cis. Okay, so when they are on the same side, you have the repelling from the both side. So this is the van der Waals strain. So this will disrupt the stability. Okay, this is one. And number two, degree of substitution. Alkyl substitution stabilize double bond. So when you have a double, now cis and trans is only for double bond, C double bond. If you have C triple bond C, this one no cis and trans, or the single bond also no cis and trans. Cis and trans only exist when it comes to the double CC double bond. Okay, so mono substituted alkene. Okay, only connected. Di substitute. Okay, tri substitute and tetra substitute. Okay, so the degree of substitution. Okay, so the more substitution, the more stable it becomes. Okay, so this will be more stable than this. This will be more stable than this. This will be more stable than mono substituted. Okay. So relative stability of substitute alkenes, you refer to this. Alright. So nomenclature of alkynes, also the same. Substitute the ANE or ENE with YNE. Okay. So if you have YNE, same thing again, you find the longest chain consisting of the triple bond. Okay, consisting of the triple bond. Alright. So you have this. It's your longest chain. 1, 2, 3, 4, 5, 6. So hex. YNE. If we start from the right, is 3. Start from the left, also 3. So 3 hexine. So this is your parent name. And then if we start, okay, so if we start from the right, our bromine will be 1, our methyl will be 5. But if we start from the left, our bromine will be 6, methyl will be 2. So this is bigger compared to this one. So that's why the correct answer is the first one, the one in blue. Okay, same goes for this, right? Naming a compound that has more than one functional group. Okay, so as compound containing 2 double bonds or 2 triple bonds, same, you have to put in diene or diene. Okay, here you have to put a diene because there's 2 triple bond. Then at which carbon number? Carbon 1, 2, 3, 4. So 1 and 4. Then only we look at the methyl group. Okay. So natural occurring alkynes are like these Lawrencine, okay, dynamicine, these are natural occurring alkynes. Cycloalkanes, already we talked about it. So cyclic saturated hydrocarbon contain a ring of carbon atoms joined by single bonds are called cycloalkanes. So cycloalkanes, if it's 3 carbon, 3 it'll be propane. So cycloalkanes normally start from 3 carbons and above. Okay, so 3 or 4 will give you a square shape, and then 5 will give you a pentagon, and then 6 will give you a hexagon. Okay, and then you have the heptagon, right? 1, 2, 3, 4, 5, 6, 7. Then you have the 8 octagon, nonagon, okay, and so on. Okay, so the naming of substituent cycloalkane is similar to that of alkanes. General formula will be similar to alkene, but you have to be very careful. Be very careful. Remember, alkene also is CnH2n. So another isomer of CnH2 of this chemical formula will be a cyclic haloalkane. Cyclic haloalkane. Same general formula as alkene. In other words, cycloalkanes are isomeric with alkenes. Found in large quantities in crude oil, cyclohexane can be synthesized by catalytic hydrogenation of benzene. So boiling point cycloalkanes are higher than corresponding alkane, and the density are slightly higher than that of corresponding alkane. So what do we mean by corresponding cycloalkanes? So propane, for example. Propane and cyclopropane. So in terms of their boiling point of cyclopropane would be higher compared to the propane itself, means the straight chain. So the cyclic alkane will have higher boiling point than the straight chain alkane. Okay, the density also will be slightly higher than the corresponding alkane. So maybe if you want to have a better understanding, maybe you can Google the boiling point for propane and cyclopropane, then you can see the difference. Okay, so chemical properties of cycloalkanes are similar to those of open chain alkanes. So in terms of physical properties, there is differences. So this one is in terms of physical properties, but in terms of reactions, okay, there are reactions, they are the same with the straight chain. Okay, so you have the chemical properties and then the physical properties, right? So in terms of physical properties, it affects, but in terms of the chemical properties, it's the same. Okay, so these are some examples of cycloalkanes. Okay, and that will be all for part 1.1.